Okay, welcome back. What I want to continue with is Sitting Gills 2357, okay? Diploma in Electrotechnology, Level 3. Now again, Level 3, okay? Unit 308. Now, what I wanted to look at today is regards to Section 4, type of faults and their locations, okay? That's what I want us to look at for today. Okay. Excuse me while I make sure I get this in full view, okay? So everything can be seen. Pan back a bit. Okay, let's just make sure we have it in full view. Okay. Okay. Now section 4, types of faults and their location. Now aims and objectives, okay? Specify the types of faults and their likely locations, etc., etc. Be able to state what, if any, special precautions should be taken as and when necessary, okay? Etc., etc., etc. Now again, it is your responsibility to read and be familiar with the IEE regulations. It is the Bible for electrical installation, okay, or electrical work basically. Whether you're doing electrics or electronics, it is still relevant. It is your responsibility to make sure you are compliant at all times with the IEE regulations. Nothing less than that. Okay, thank you. Let's pan that back a bit so we can make sure we get it in full view. Now what we're looking at here is wiring systems, okay? Now the wiring system. Now the types of faults possible in wiring systems is fairly broad, and it would be impossible to list every type of fault. However, we can discuss the more common ones, okay? Let's make sure we're in view. Okay, good. Now general purpose PVC, insulation failure, cables being pinched or hit by nails, okay, and that's a common fault. Overheating, potential short circuits, etc., insulation failure. Now conduit, now problems here again, high resistance from joints not being tight, etc. Short circuit when cables are trapped. Now with regards to the conduit, what you have to bear in mind also is that when you're pulling cables into conduit, it is important that the conduit has been cleaned. The end of the conduit has been removed, okay, to make sure that there's no burrs on the end of the conduit. Otherwise, what happens, those burrs will strip the cable, the insulation on the cable, right down to its bare conductor. And when you power on, that will be your mighty bang you hear when you do switch on that power, okay? So it is important that when you're dealing with conduit or trunking, that your ends are clean and that the risk of burrs is removed. Okay, let me just take this a different angle, make sure we can, it does not come back in, come out, okay. 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 Now here we have MI, mineral insulated cable FP200, and please note also, although we have FP200, I believe we have FP400 as well, but please confirm that for yourself, because there was, to my knowledge, an upgrading of certain cables to make them more fire resistant. Okay, but don't take my word for it. It's important that you are familiar. Again, look in the IE regs. That will tell you exactly what standards of fire resistant cables there are. Okay. And again, you have to read this for yourself. MI cables, the making of the joints is very important. Okay, you make a mistake on these joints and they will short circuit and they will give you an almighty bang, especially if they're feeding motors, etc., three-phase systems. That's important that you understand that. Okay, just pan back, make sure that we have the full screen view so everyone can see it basically. Okay, good. Again, this is for you to read through, get familiar with. It's not there for my good looks and charms, because I'm handsome and good looking. Now, terminations and connections. As it says here, loose connections, different metal connections actually, we call it oxidization. Okay, basically cause the metal to corrode away. So it's important that aluminum and copper do not like each other chemically. When they are in direct contact, they react with each other and there is a resistance increase at the point of connection. So again, you need to be aware that aluminium needs to be connected to aluminium, copper needs to be connected to copper to minimize and remove this risk. That is imperative. Now, I am aware that I might be speaking a little fast, so what I will try and do is to slow it down. Okay, so it's okay, it's just my little excitement. I get excited about what I do. Okay, termination and connections. And here, this is for you to read yourselves. I don't need to read this to you in the least at all. Okay. Okay. Luminaires. Okay. Okay. Right, that's for you to read. Okay, don't need me to read this to you. Again, you can capable of doing it for yourselves. And again, don't forget to use the zoom on your own equipment to view this better, because some of you have probably got better equipment than myself. I'm just a poor man, pauper. Instrumentation and metering. Instruments are used. Let's go into this closely. Instruments are used in installations to measure current, voltage, power factor, and power. It is common for current and voltage transformers to be used for this, etc., etc. Okay, let me make sure I get this down for you. Let's pan back. Okay. Okay. Protective devices. Okay, let me just make sure we got that in view. Okay. Okay. Good. That's for you to read. I don't need to read this for you at all. Okay. And again, protective devices continues. Okay. Special precautions that need to be taken. Okay. Now, often you'll hear someone says, "We are going to consider." Okay, sorry. Let me rephrase that a moment. We are going to consider 8 specific areas where additional precautions need to be considered. Lone working. Never ever work on your own. Okay. You'll hear someone say, "Oh, it's only going to be a 5-minute job." There's no such thing as a 5-minute job in the electrical trade. If you are a meter reader, maybe it's a 5-minute job, but you are not meter readers, you are electricians dealing with a live conductor or a source of energy that could kill you before you could blink. Okay? So when you're dealing with lone work, you never work alone. That is paramount. Okay? You always have someone with you at all times. Now you may think that I'm only going to look at this, but the problem with working on your own is that if something happens to you, you cannot scream, you cannot make a noise, you cannot wave your hands. If you have a short circuit between you and a conductor, you will not make any noise, you will be dead. Okay? And the main aim of this is to ensure that you get back home in one piece to your loving wife and family or girlfriend. And for those of you who are beautiful women and girlfriends, I just hope that you will take this to heart and heed this. Because nothing worse than me having to go and give bad news. I hate that. Okay. Long looking. Okay, so here we are, and it's telling you reasons why lone working is not a good idea, and you don't have to take my view for it. You can see there that in any circumstances, it is never a good idea to work alone. Okay, I'll pan back a bit so we get this interview. Okay. Okay, good. Good. And again here you have regulation 6. Make sure that it is still concurrent in regards to your current regulations in regards to the 18th edition. Be aware the 19th edition is probably on its way already, so be aware of that. Okay. Okay. Fiber optic cables, okay. Now here are the issues we have with fiber optic. Although it is a good medium of travel in regards to electrical signals and transmission, it has certain flaws. Now be aware of those flaws, make sure you can comply with those flaws and you understand what is required of you. Okay. Okay. Now, electrostatic discharge, again, a serious issue to be dealt with, especially if you're dealing with electronics. Use your discharger. Must be connected to a point of discharge so that any static electricity buildup in your body is discharged to ground, okay, and not through the component that you're trying to fix. And here are some of the places where electrostatic discharge is required, and it's showing you here how it is implemented. Okay. Okay. Electronic equipment, and here we are just telling you what electronic, how they can be damaged, etc. That's for you to read, okay, for yourselves. Make sure you're familiar with it. Let me just make sure that it can be, it's in view. Okay, good. Now IT equipment, okay. Don't bother hit it with a hammer. That's not going to work. Okay. High frequency or capacitive circuits. Variation frequency can cause major problems to items of equipment, and the use of systems that create high frequencies can lead to damage. High frequency supplies can also cause burns. In addition, certain items of office equipment such as power supplies can have very large capacitors present. Now, so it is important that you keep this in mind in any work that you undertake in regards to high frequency. Look at what the IE regulation stipulates in regard to dealing and ensuring safety at all times. Okay. Storage batteries. Okay. Storage batteries was used for backup power supply at one point in time, but because most people are now moving to generators as a backup means, storage supply in regard to batteries are becoming less frequent. But that does not mean that you don't need to know about it. You still do need to know about it, okay? And that's what it's about. Okay, I hope you found this useful, and again, I trust you will continue to look through my work. There are stacks of videos that you need to look at in regards to this type of lesson, in regards to sitting girls 2357 and 5357 electrical installation. Look at the videos themselves, go into the separate sections and into the playlist, and if you go into the playlist you'll find that you have a lot of information and access there to work from. Okay, thank you for your time. I hope you found this useful. Have a good day. Bye bye.